On September 7th, 2010, a Chinese fishing trawler rammed two Japanese Coast Guard vessels near a disputed cluster of islands in the East China Sea. Japan arrested the trawler's captain. Standard procedure. A diplomatic incident. But what happened next was not standard. Within weeks, Japanese manufacturers started getting the call. Their rare earth shipments from China had stopped. No formal announcement. No official embargo. Just silence from suppliers. And according to the World Economic Forum, at that point, Japan was importing nearly 90% of its rare earths from China. Hybrid car production lines were threatened, wind turbine components, precision electronics, even components used in defense systems. The world had just seen something it was not supposed to see. One country, with one quiet decision, had come close to switching off the supply chain for the technologies that define modern life. And the infrastructure that allowed it to happen is still intact today. Rare earth elements are a group of 17 metals with names most people cannot pronounce. Neodymium, dysprosium, terbium, praseodymium. Despite the name, they are not especially rare in the Earth's crust. But they almost never occur in concentrated deposits. Mining them means processing enormous volumes of rock to extract tiny yields. And that process generates toxic byproducts and, in some deposits, low-level radioactive waste. But there is no engineering alternative. A neodymium magnet is the only reason your electric car motor is compact enough to fit in a vehicle. Dysprosium is what keeps that magnet from demagnetizing when the motor heats up. Terbium goes into the phosphors that make your phone screen function at all. According to the International Energy Agency, rare earth permanent magnets are critical to electric vehicle motors, offshore wind turbines, and a growing range of defense technologies. You cannot engineer your way around them. They are embedded in the physics of the devices. Until the early 1990s, the United States was one of the world's largest producers of rare earths. The Mountain Pass mine in California's Mojave Desert led global output. The rare earth supply chain was, in a meaningful sense, American. But through the 1990s and into the 2000s, Chinese producers entered the market with state subsidies, lower labor costs, and environmental standards that would have been illegal in the West. According to the U.S. Geological Survey, China went from producing around 31,000 metric tons of rare earth oxides in 1994 to over 270,000 metric tons by 2024. Mountain Pass could not compete on price. It closed in 2002. Then again, in 2015. The American rare earth industry did not just shrink. It hollowed out. The knowledge base, the processing infrastructure, the supply networks, all of it migrated east. But here is the part that most trade briefings leave out. China did not just win the mining race. It won something far more important. Getting rare earths out of the ground is only the first step. The material that comes out of a mine is ore. To turn ore into the separated elements that manufacturers actually need, you have to run it through a chemical refining process called solvent extraction. It requires specialized facilities, proprietary chemistry, and years of operational expertise to do at scale. According to the IEA, China controls approximately 91% of global rare earth separation and refining capacity. This is the choke point the 2010 Japan incident revealed. Japan was not just dependent on Chinese mines, it was dependent on Chinese chemistry. Today, the United States has one operating rare earth mine, Mountain Pass. Until recently, the ore it extracted was being shipped to China for processing, then shipped back as finished material for American manufacturers. America was mining its own rare earths and sending them to a strategic rival for refinement. That is the system that existed, but it gets worse. Even if you solve the processing problem, you still face the magnet problem. According to CSIS, China manufactures between 90 and 98% of the world's neodymium iron boron permanent magnets. These are the magnets that go into EV motors, wind turbines, and defense systems. Japan and Germany produce most of the remainder, but both countries depend on Chinese raw material to do it. The US Department of Defense set a goal to develop a domestic mine-to-magnet supply chain capable of meeting all defense needs by 2027. Since 2020, the Pentagon has committed over $439 million toward that effort, according to CSIS. But in 2024, MP Materials produced 1,300 metric tons of neodymium praseodymium oxide. In that same year, China produced an estimated 300,000 metric tons of NdFeB magnets. The gap between intent and capacity is not a policy gap. It is an industrial gap. And it took decades to build. In December 2024, China banned exports of germanium, gallium, and antimony to the United States, three materials critical to semiconductor manufacturing and defense applications. According to the Resources for the Future Institute, This was followed in April 2025 by broader rare earth export licensing controls, imposed in direct response to US tariffs. 7 rare earth elements added to the restricted list. Then, in October 2025, Beijing went further, threatening to restrict any product containing even trace amounts of those elements. And by December 2025, according to CSIS, China moved to block rare earth exports tied to foreign defense supply chains entirely. MP Materials announced it would stop shipping its ore to China for processing. The company said it would stockpile material while working to build out domestic separation capacity. That is where the system stands. One mine, partial processing capability, a magnet industry that barely exists, a supply chain that was quietly handed to a strategic rival over 30 years while no one was watching. The 2010 Japan incident was a warning. The world read it, nodded, and largely went back to the same dependency. The question now is whether what is happening in 2025 is the moment that finally forces a change, or whether it is just another warning that gets filed away. The rare earth supply chain was not built in a crisis. It will not be rebuilt in one either. The story of rare earths is the story of every critical infrastructure this channel investigates. The choke points do not appear overnight. They are built slowly, through decades of decisions that made sense at the time, and only reveal their danger much later. If you want to see how another invisible choke point works, and what happens when ships stop moving through it, the Strait of Hormuz video is on screen now.